Well, sorry guys, I had a little power outage with my camera there right in the middle of finishing this problem. So we're almost done. I just want to finish this problem and then do maybe one or two more quick examples to show you how this works. So we were in the process of taking this particular solution right here, and we're trying to solve for the particular values of A and B. So I've taken the derivatives of that particular solution. I need two derivatives in order to really plug into this problem that we're solving. And then I took those derivatives and plugged them in on the left side, and I set it equal to the right-hand side. So what I was saying is that you can group all of the cosine terms and all of the sine terms together, and the sine terms has to add up to 10 because there's 10 sine of x on the right side. But there's no cosine of x's on the right side, so the cosine term has to be 0. So if you look at the cosine term, it's actually just negative 3a minus b. That has to equal 0. And the sine term is a minus 3b, and that has to equal 10. Okay? So if you then just solve this little system here, it turns out that, I'll let you solve it because it's an easy thing to do. A is equal to 1 and B is equal to negative 3. A is equal to 1 and B is equal to negative 3. Okay? So what that means then is that your particular solution, let me just come back over here, right? Your particular solution then is just cosine of x minus 3 times sine of x. So I've just put in the a equals 1 and the b equals negative 3 into the particular solution. Okay, and so my final answer then, this is step 3. Step 3, we just put the complementary function, c1 e to the 2x, plus c2 e to the negative x, plus the particular solution, cosine of x minus 3 times sine of x. That would be the answer for step 3. Okay? It takes a lot of work sometimes to actually solve for the constants a and b. So sometimes I will only ask you to give me the form of the particular solution. Please read the questions very carefully. If I only ask you to give me the form of the particular solution, then you don't have to solve for a and b. You can just give me the answer with the a and the b, or whatever variables there are, with those constants just in there. Let me give you an example of that, okay? So suppose I asked you to solve the following problem: d squared minus 4d plus 5 of y equals 8x e to the 2x cosine of x. Okay, let's suppose I asked you to solve that. All right? So while I'm erasing, maybe you can try and write down the auxiliary polynomial for the homogeneous differential equation. We can get the complementary function going. This is very easy. Remember that all of the d's just turn into r's. So r squared minus 4r plus 5 equals 0. It looks like that's going to factor nicely, but it turns out it doesn't. If we use the quadratic formula on that, what you're going to get is this expression right here. Okay? So make sure you know that quadratic formula really well. You're actually going to end up with two complex roots. So 2 plus or minus, actually this just becomes I, right? Square root of negative 4 is 2i. When you divide by 2, you get I. All right, so that means that my complementary function is going to be c1 e to the 2x cosine of x plus c2 e to the 2x sine of x. Okay, that's based on section 8.2, going back to the previous section. This is my complementary function. When I have imaginary roots, I'm going to get sines and cosines, right? And there's a real component here of 2, which is why we see the e to the 2x there. Okay, now in terms of step 2, we have to look for an annihilator for for the right-hand side. Now the 8 doesn't matter, but this x e to the 2x cosine of x part does make a difference, right? So we have to write down the annihilator for that. And the annihilator for that is something you can get from your table. Because of the x, you're going to be squaring the annihilator. And then the e to the 2x cosine of x part, that's going to give you, actually, it's just going to give you d squared minus 4d plus 5. Okay? And now, these roots right here, these are what I like to call the old roots. Okay? Those are the roots that come from step 1, the original auxiliary equation. But if you look here, you're going to get, from this annihilator, when you apply it to the differential equation in order to zero out the right side, you're going to get 2 plus and minus I 2 more times. And now I have to consider, those are the same roots again, but now I'm viewing them as being new. These are now new roots because they're coming in step 2. So if I think about the particular solution, right? Remember, you're going to start with these two terms. If we are repeating roots, right? If we have repeat roots, we have to stack those x's in front of these terms, don't we? So it's going to look like this. It's going to be a times x e to the 2x cosine of x plus b x e to the 2x sine of x. That handles the first set of repeats of 2 plus or minus I. But I have to keep going because it's repeated again. So c x squared e to the 2x cosine of x plus dx squared e to the 2x sine of x. A little bit of tight space there. This is the form of your particular solution. Okay, you've got the complementary terms with the c1 and c2 in front of them. And then these are the terms coming from the particular solution. And they reflect the fact that the new roots, 2 plus or minus I, are already occurring here for the second and third times. So we have x's for the second occurrence and x squareds for the third occurrence. All right? Now, to find a, b, c, and d, we would need to plug that guess, or that form, I'm sorry, into the original differential equation. It means I'm going to have to take 2 derivatives of this. And you can see that with all these x's here, the product rules are going to get disastrous. It's going to be a mess. Okay, so it's too hard. It's not really conceptually hard, it's just messy hard to find A, B, C, and D. So what you would give is that you would just simply write down the form of the answer. And the way that that would look is y of x equals c1 e to the, you just put down the complementary function again. Okay, so there's the complementary function. And then you would just add the form of the particular solution. So you would just add to that ax, so this is plus ax e to the 2x cosine of x plus b x e to the 2x sine of x plus cx squared, right? E to the 2x cosine of x. I'm just recopying what's right above me here. X squared e to the 2x sine of x. That would be the form of your answer. Okay? So sometimes it can be a little bit painful to work out the constants. And in those situations, I'm perfectly okay if you don't want to actually take the time to do that. Okay? But you should just read the questions carefully. If I want you to only find the form of the particular solution, I will usually just say so. All right? If I don't say anything, and I just say solve the problem, then that probably means I want you to actually find the constants. Okay? I hope this makes sense. This is a little preview of 8.3. We can always talk some more about this in class when I get back, or in my office hours, of course. Hope that this made sense. Hope you enjoyed it, and I will look forward to seeing you guys again real soon. Have a great day. Thanks.